Assalamualaikum warahmatullahi wabarakatuh. Hi everyone, this is Syari. So in this video, I would like to continue where I stopped in the previous video, which I've already talked about the basics for control charts. Today, I'm just going to probably finish off the rest of the topic in this chapter by Montgomery. So the rest of the magnificent 7 histogram, check sheet, Pareto, cause effect diagram. I think many of you probably have some knowledge of this and have seen it before. But for those who are new, probably you need to read up and see more of what are the material, what are the texts have actually explained about this. So a check sheet can be used to record all the defects that is happening in the process, whether it is a production process, service process. You can always design a check sheet to collect data. Okay. So you want to, for example, this is defect data for this process, and this is the defects types, and you want to actually find out the frequency of occurrence for the different types of defects. Like for example, this is past damage, machining problems, and so on. Why it is important to know these the defects so that you can actually do improvement. So the whole idea of quality is to find out what kind of defects we are producing. This is a check sheet to record defects on a tank used in aerospace application. Okay, so check sheet is important before we can actually construct the Pareto chart. Okay. So from that check sheet, we can actually determine the highest to the lowest. So its Pareto chart is ranking the highest frequency of occurrences of types of defects, or for any matter, any type of classifications that you can think of: inventories, safety issues, the accidents, locations, and it is based on 80-20 rule. So 80-20 rule means 80% of problems of frequency is coming from only 2 or 3 items, so 20% of the items. So 80% impact. This probably this first 3 is having the highest impact. If you calculate the cumulative percentage, you find that it is close to 80%. It's not must get 80%. It's it's 80-20 rule. So examples of Pareto chart. So this is cumulatively 80%. So this first 3 defects is actually constitute the most frequent occurrence, and you want to solve that first. Okay, you look at the number of defective for the components. So you can do various kinds of Pareto charts. You can analyze even for your daily life. 80% of your time is spent doing what? So that you want to improve your productivity. So that's very important for purpose of improvement. Okay. The other chart tool that is commonly used is cause and effect diagram. Cause and effect diagram is done through a team, and it is a brainstorm. So you decide on the problem, or this is the effect part of the chart, and these are the possible causes. These are the main cause. Okay, normally we use the factors for production: man, machine, method, materials. Well, you can change that to environment if you want. Personnel, you can change to, if it is a university setting, you can change this to the lecturers. So it is also known as the Ishikawa diagram. which is named after Kaoru Ishikawa, one of the famous quality gurus. And you can brainstorm. It is so powerful. But of course, at the end of the day, you don't want to, these are the possible causes. And further to that, the group will decide which, for example, need to be investigated further. For example, defects on tanks, if it is decided that it's part of the quality improvement activities, that you need to further investigate the viscosity of the primer. So you can use other tools like scatter diagrams, or you can use control charts to see whether the process on the viscosity is within the control limits or not. So this gives you direction in which for you to do further investigation and further study to understand the process further. Right, it's a powerful tool that is being used, that has been used by many organizations. Right, this will describe how to construct a cause and effect diagram. First, define the problem to be analyzed or effect. I've done this before, just looking at example of problem of English ability to command, English command within Malaysian students. Why is the command of English is poor command, poor English among, for example, Malays? Enough, students have told me that, why? Because they are shy to speak English. They are being made ashamed by their fellow friends. Teasing them for speaking in English. So, or even teaching method. Teaching a language in your own mother tongue language is probably one of the best way of destroying the ability to learn the language. You do not teach a foreign language in your own mother tongue language. You should teach foreign language in the foreign language. So you can use this cause and effect diagram tremendously. Okay, it's, form the team. You draw the effect box. Specify the major potential causes, and join them as boxes. And identify the possible causes and classify them into the categories. Sometimes you may want to just list up, then probably put into this what they call diagram. But I just want to point out that you need to actually have another arrow. For example, paint viscosity. What about paint viscosity that you need to go into the third level? This is the big bone, this is the medium bone, this is the fine, smaller bone. Probably low viscosity. Okay, so that will be actually trying to go to a third level of understanding. And normally, to brainstorm this, we use the 5 why techniques. Okay, 5 why. Why is the viscosity poor? Okay, why is it low viscosity? So you get to the root cause of the problem. Okay, so anything in our life, we should always ask 5 why. Why am I lazy? Get an answer. From that answer, you ask another why am I that? You ask another why until you get to the root cause. Okay, it's just a sideline trying to share my experience and my opinion on this. So identify the possible causes, rank the causes, rank order the causes, identify those that seem most likely to impact the problem. Okay, so you can actually get all these causes and get the team to rank them. So if, for example, the viscosity happen to be the highest rank, that means all the team members agree that it is the most possible cause that actually resulted into the defects on the tanks. Then that is the reason that you want to investigate further and tackle upon it and try to countermeasure. Countermeasure means solving it. solving it, and take corrective action. So countermeasure means taking corrective action, permanent corrective action, not temporary corrective action. Permanent corrective action requires us to determine the root cause and eliminate the root cause of the problem. So even in our society, in our life, in our work, we know what the root cause of the problem, and we need to remove it from the process. Then only we can improve the process. There is also defect concentration diagram. It's just another word for location. Okay, that means where's the highest defect occurring in which location. Okay, defect concentration diagram, powerful. You can sketch any parts or any components, left hand side, right hand side, and you can start actually counting the number of defects. You start making a tally chart. But today you can use computers, you can use software to actually do this. Scatter diagram is also a control 7 tools. Basically, it is a linear regression, and the Japanese able to actually try to simplify the linear regression scatter diagram to see the relationship between one variable and another variable. So we have two variables. Of course, the limitation is we only have two variables, and we want to find the relationship between metal recovery and reclaim flux. You can measure between the content of the chemical, carbon chemical against the strength of the material, strength of the rubber, for example. Or you can see classic examples seen in many books. For example, the negative correlation between the fuel miles per gallon that you actually get when you actually the speed of the vehicle or the car. Okay, it's a negative correlation. You can see in other books, because correlation, you can have positive correlation, you can have a negative correlation, or you don't know whether there is a correlation or not. Okay, so no correlation. So when you know there is no correlation, it gives you indication you don't want to control a certain variable in order to get the response or the output or the outcome. So implementing SPC in a quality improvement program, the elements of successful SPC program requires management leadership, a team approach, education of employees at all levels, emphasis on reducing variability. Variability is our enemy, our culprit, because if there is variability in terms of skills of workers, then it will actually result into producing different levels of quality output at the end of the production line. Okay, so that is why in all production processes we have standard operating procedures. There are ways and methods of steps by steps to actually, for example, install a certain component, install the wheel, the tire onto a car, a vehicle. So there is this cross tightening of bolts. You cannot cross 1, 2, 3, 4, but it's 1, 2, 3, 4. I think those who understand me will appreciate what I'm trying to express and tell you. SOP. Same like today when we have COVID SOP, because to break the chain of transmission of the coronavirus disease. Okay, measuring success in quantitative terms. Yes, we have to measure, for example, Pareto. Pareto, we can actually put in the cost component. We can actually say repair dollars. We can look at how much this defect, because probably if it is repaired, it can be repaired, or the damage, how much it costs per damage. 98 times 100, for example, ringgit, 80 times 50 ringgit, and convert that into cost Pareto chart. You can analyze which is the highest loss to the company. So remember that, you need to measure in terms of quantitative, loss cost to quality cost. Okay, I have a video on that quality cost, loss to the company. So we don't want loss to the company to be transferred to customers to pay for the cost of inefficiencies in the organization. The organization produces a lot of defects, and obviously these defects are going to be accounted into the price of the product, definitely. Okay, so we are paying for the inefficiencies that exist in organizations, so we don't want to do that. Okay, and a mechanism for communicating successful results throughout the organization. So we can have a look at an application of SPC. What this is trying to improve quality in a copper plating operation at the PCB fabrication plant. So they have used the DMIAC process. Well, DMIAC is another, Six Sigma approach, but don't worry about that. It's a defined measure, analyze, improve, and control. So you want to define the step. The team decided to focus. It's team effort. Remember, quality improvement is always a team effort. Okay, and you need data. And then during the measure step, controller downtime was recognized as a major factor in excessive flow time. So it's describing the application of that. And they actually use the cause and effect diagram to determine the possible causes of the problem, okay, the controller downtime. So it's very structured and very systematic way of thinking of trying to solve the problem. And they started to collect some data. This is actually for the logbook, and they did the Pareto analysis for the controller failures. So the concentration variation was the highest. Second was followed by the tubing maintenance. So you can immediately focus your improvement activities on the highest what they call ranking category. Okay, and they further analyze the concentration variation. So you can further make this and collect data to construct another Pareto. So in this case, it is calorimeter, reagents, and whatnot. Okay, so you further analyze with the Pareto, and they constructed a X bar R chart for the average daily concentration. For the product, for the what they call the concentration variation, okay, and the R chart. So you can see here, this is good range, fluctuation in the dispersion. This is not good. Okay, this process is actually not within statistical control. Okay, they can also look at the tolerance diagram. So there are other tools. There are many other tools that can be used. And design experiment, I have not talked about this, but this can also be part of the improvement activities, trying to determine the best combination of the parameters in the process. So you see here, these are the parameters: copper concentration, sodium hydroxide concentration, formaldehyde concentration, temperature, oxygen, set at a low and high level. Okay, so this is DOE, design experiment. So SPC can be used in not only manufacturing but also in service businesses as well as transactional, processes or activities. So you can it's up to your imagination to think of what to improve. So you can use flow charts, you can use operation process charts and value stream mapping. This is picked up from lean manufacturing tool, okay, value stream mapping, to actually eliminate non-value added activities. So ways to eliminate non-value added activities: rearrange the sequence of work steps. This is particularly for service organizations. Rearrange the physical location, change the work methods. But it's not as easy as this actually. You need to actually do a lot of work to find out. Okay, it's not. Change the type of equipment. Redesign forms and documents for more efficient use. Okay, improve operator training, supervision, try to eliminate unnecessary steps, identify more clearly the function of process to all employees, consolidate process steps. There are steps which can be combined. You know, you have to always be creative to ask whether is this step necessary. Why is the worker doing this step? Why is the clerk, having to do this step? And the typical process chart symbols is widely used in industrial engineering applications or in process improvement applications: operation, inspection, movement, delay, storage. And very important to flow chart process. Flow chart of an assembly portion of Form 1040 tax return process. It's a tax return process. You can look at the steps from, from maybe start from, copy files, cut vouchers, and then mailing this. Okay, this is attach envelopes to signer. But you understand the process, you can actually document and think about it and develop the process chart of the assembly portion. Another tool, value stream mapping, VSM, a value stream map, can be used in service organization, can be used in manufacturing organization, production situation. So typical symbols, supplier, shipment, movement. So the whole idea is VSM is to find the non-value at the time and the value at the time of process. So we want to determine where non-value added activities are being performed by happening in the process, whether it's from the equipment, man, and so on. Okay, I'm not going to go to this detail. Okay, so next time if I have opportunity, I will talk about VSM in much more detail under lean manufacturing. So thank you for listening. I hope you will benefit from my short talk, sharing today, and